So in the last video, we talked about how to derive the equation for velocity as a function of time. And what we want to do in this video is find an expression for the position of an object, the position of an object as a function of time. So what we need to remember is that the units for velocity are change in position over change in time. And the units for position are just change in position. So what we want to do is see what happens when we take the antiderivative of velocity with respect to time. So let's take the antiderivative of v of t dt, and we'll set that equal to the antiderivative of gt plus v naught with respect to time. So the antiderivative of velocity with respect to time is position, because the derivative of position with respect to time is velocity. So we can write s of t equals, now we have to take the antiderivative of this, so with respect to time. So what we're going to do is take the antiderivative of gt with respect to time. So that will be, if you increase the power of t by 1, you'll get gt squared. And dividing by the new power, you'll be left with 1/2. So 1/2 gt squared. The antiderivative of v naught is v naught t. And then with antiderivatives, you always have to add the constant of integration, which I left out in the last video. I didn't emphasize it as much. And this is the constant of integration. And the reason for this is because if you take the derivative of this with any constant here, the constant will go away and you can be left with this as the antiderivative, or as the derivative, I'm sorry. So what we want to do is solve for the constant of integration. So we're going to do that by plugging in 0 for time. So let's find out what happens if we say that the position at time 0 equals 1/2 times the acceleration due to gravity. Now we're plugging in 0 here, so times 0 squared plus v naught times 0 and plus c, which is what we're looking for. Now we can say, we can rewrite s parentheses 0, we can rewrite that as s sub 0. So this is the initial position. And we can say that that equals, well, this is 0 because it's 0 squared times 1/2 g, and v naught times 0 is also 0. So s naught equals our c value. Now we found what this equals. So we can say that s of t equals 1/2 times gt squared plus v naught t plus s naught. And now we have a way of describing the position of an object thrown as a function of time. Thanks for watching.